Okay, ACT class, if you missed class today or if you want to review what we did in class today, my recording equipment did not work. It was human error, not my computer. Unfortunately, I had the wrong settings on there. So I decided what I would do if you wanted to review what we did today is go ahead and work the same ACT problems I did in class, but do them very quickly. So here's what you're going to have to do. If you're watching this video, which you obviously are, you're going to have to hit pause, read the problem, and try to work it. And then when you've done what you can, if you can do anything at all, turn it back on and watch me. In some cases, I may give you a hint or two, in which case you may want to pause it again after that hint or two and see if you can finish it. But do your best to do these things and learn these procedures and learn how to do these problems. So let's look at a problem here. I'll let you read it. And what you need to do, I'm not going to wait. Just hit pause and read the problem. And then I'll do the problem, and you can try to do the problem without watching me first if you can. Then I'll do the problem immediately. So you're going to have to hit pause. Okay, here's the problem. So it's telling you that Madeline and Lydia have laid out a map of their neighborhood in XY coordinates with each unit equal to 1 mile. If their house is at the point 2, -4, their grandmother's house is at the point 7, 3, how far apart in miles are the two houses? So you're going to have to draw a Cartesian coordinate plane. And theoretically, you're going to have to remember the distance formula unless you can figure out a way around it. Maybe you can, at least maybe to get a reasonable guess in there. So I'm looking at these 2 points. I'll call this one X1 and Y1 and X2 and Y2. It doesn't matter. You could call this one X1, in which case this would be Y1. This would be X2 and Y2. Once you pick an X1, it has to be one of these, then the other has to be right. And I'm going to go ahead and graph them so I can see them, although you don't really have to if you remember the distance formula. Do you remember the distance formula? Can you write it down? Pause and see if you can write it down. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So if you remember that, you can plug these things in. I would strongly recommend you label these things on your test booklet so you don't get confused and put the wrong number as a substitution, for the wrong variable. So x2 minus x1 would be 7 minus 2. I'll go ahead and write it down. On the real test, you wouldn't do that. You just do it in your head real quickly. And y2 minus y1 would be 3 minus -4. And of course, this is square root of 7 minus 2 is 5. 5 squared is 25. 3 plus 4, 3 minus -4 is 3 plus 4. That's 7. 7 squared is 49. So you get the square root of 74. And there it is. So if you remember the distance formula, you can probably almost do it in your head. A lot of it, you wouldn't want to write all this stuff down, probably, if you remember it. Plug it in and do the problem. Now, what if you don't remember the distance formula? If it's going to be the situation for some of you, you get on the test and you go, wait a minute, I don't remember what it was. Well, here's what you could do. You could plot these points. It goes up to 7 here on X. 1, 2, 3, 4, 5, 6, 7. I wouldn't do this on the real test either. This takes up time. I would just kind of guess at it. 1, 2, 3, 4, 5, 6, 7, and up 3. I wouldn't mark all the tick marks. It just takes time. So this is 7, 3. The other one is 2, -4. 2 and down 4. Right down here. 2, -4. Okay? Now, there are a couple of things you can do. You're looking for the length of this thing. How far apart in miles are the two houses? Here's one house, here's the other house. So you're wondering what this distance right here is. Well, another possibility would be, if you didn't remember the distance formula, to just realize, well, X is going from 2 to 7. That's 5 units. And Y is going from -4 up to 3. That's 7 units. And now I can use the Pythagorean theorem. 25 plus 49 equals the square of this. So that equals the square root of 25 plus 49. Same thing there. You can do that. Here's another possibility. Let me grab my calculator real quickly. I can find it. It's a big if. Oh, there it is. Let me show you something else you could do. You could plug these numbers into your calculator. 2 times square root of 6. That's 4.9. 24. Square root of 74 is 8.6. Square root of there's 74. Square root of 130. I can tell you even a quicker way to do this is 11.4. You could say this is between, 2 and 3. So this is between 2 times 2 is 4 and 2 times 3 is 6. It's somewhere between 4 and 6. This is between, you see what I'm doing here? The square of 2 is 4. The square of 3 is 9. So I know it's between 2 and 3. This is between the square of 8 is 64. The square of 9 is 81. So it's between 8 and 9. Between 8 and 9. This is the square of 11 is 121. The square of 12 is 144. Square of, I'm not saying square root, square. So it's between 11 and 12. So you can do that pretty quickly mentally also. And when you look at this, you say, well, that's 5 and that's 7. So do these make sense? Well, this one makes no sense at all. That's less than 5. That doesn't make any sense. 24, that's way too big. That doesn't make any sense. That one makes sense. Of course, it's correct. 74, that's way too big. That doesn't make any sense. That one might confuse you a little bit, but at least you would say, I've got a pretty good guess between these two. And this brings a more reasonable guess. You see what I'm doing there? That kind of thinking can really help you on the ACT. Make reasonable guesses, and sometimes you can at least eliminate a lot of bad guesses, right? Yeah. Okay. You didn't understand that? Rewind it. Watch it again. Let's see. Let's just. All right, the midpoint between these 2 points on the Cartesian coordinate plane. Here you go again. Here's a point 1. Here's point 2. The midpoint is this point right here between them, exactly between them. It's the midpoint. And you find it by averaging the x's and averaging the y's. You get an x here and an x here, x1 and x2, add them together, divide by 2, and add the y's together, y1 plus y2 divided by 2, and that'll give you the midpoint. This is x at the midpoint, this is y at the midpoint. That's all you have to do. And it would be nice to remember that little equation if you could remember it. It will make some problems easier. However, there are workarounds. So I would encourage you to memorize that. It's not that hard of an equation. It makes sense. Add the x's, divide by 2, add the y's, divide by 2. It's a midpoint. So here's one that says, read it, pause, try it yourself. The standard xy coordinate plane, in the standard xy coordinate plane, the diameter of a circle has endpoints 5, -2, and -3, 2. So they've got a circle, and it has a diameter, and 5 and -2. I'm just going to kind of guess at it here. 5 and -2, and -3, 2, -3, 2. So I'm going right 5 and down 2, and I'm going left 3 and up 2. I'm just kind of making up my tick marks in my head to save time. What are the coordinates of the center of the circle? Well, if this is the diameter of a circle, the center's going to be somewhere, right in here, roughly. So it may not look right. I'm not trying to get exact here, and I'll show you why. Because when I plot these points, 4, -2, 4 to the right and 2 down, 4 to the right and 2 down, that's -2, so it'd be right about there. That doesn't look like the center of that line, does it? You scratch that one out. -4, -2. -4 would be farther to the left here and 2 down. That doesn't make any sense either. It's nowhere close to the center line. So you don't have to remember the midpoint. Just check these things out. -1, 2, -1, up 2. As high as this. No, that can't be. These are all ridiculous. 2, 0, 2 to the right. Says, well, that's pretty close. That looks like that could be good, doesn't it? 1, 0, 1, could be either one of those. So you're going to have to guess, but you sure wouldn't want to guess those two. I mean, those three. You got at least a 50-50 chance. Now, if you add them up, 5 and -3, x1 plus x2, that's 2. 2 divided by 2 is 1. You've already got it. X is 1. -2 and 2 add up to 0. 0 divided by 2 is 0. So 1, 0 is the point. If you remember the formula, it's easy just to plug them in and do it in your head. So it's nice to remember the formula. But if you forget it, just draw it and realize, wow, it can't be these. And you narrowed it down to 2 anyway. Okay. All right. Vertices of a square, the standard xy coordinate plane have the coordinates 3, -5, 7, -1, 3, 3, or the coordinates of the fourth vertex. Don't just watch me work it. Stop this thing and watch it. See if you can do it yourself. So what you're going to do, of course, is plot these points. Uh-oh. A dried up marker here. All right, 3, -5. 3, -5. 7, -1. 7, -1. 3, 3. 3, 3. Notice I'm being, sort of careful. I'm not just being stupid careless, but I'm making a pretty good approximation of where those points would be. I don't have to be exact. Well, the coordinates of the fourth vertex. All right. Let's do the same thing we did a while ago. -4, 5. -4, 5. Obviously not. -4, 1. Well, -1, -1. That looks like a possibility, doesn't it? -1, 7. Nope. -4, -2. I guess I better go down a little bit farther. Nope. That's got to be it, hasn't it? And when you look at it, you realize, you know what? This X and this X are the same. So these are on a vertical line. So these must be on a horizontal line. So Y's got to be -1 over here also. So that's the only one that has Y as a -1. Make sense? It's H. All right. Read that one. See if you can do it. Pause this while you work it. It's the slope of a line perpendicular to the line given by the equation 6x plus 3y equals 9. All right. This requires you to know certain things. What do you have to know? You have to know how to find the slope of this line in order to find the slope of a line perpendicular to it. How do you find the slope of that line? Well, you've got to remember the slope-intercept form of a linear equation. You remember it? Can you write it down? Y equals mx plus b. Slope is m. B is the y-intercept, but that's the slope. So I've got to make this look like this. Can you do it? See if you can do it before I do it. 6x plus 3y equals 9. Solve for y. I'm going to subtract 6x from both sides and divide both sides by 3. There's my slope. So you got to know how to do that. But you also have to know what that means as far as the slopes are concerned. If it had asked for a parallel line, a slope of a parallel line, then you know if they're parallel lines, they're the same steepness, so the slope must be the same, right? So if it's a parallel line, that would be the answer. But that's not the answer here. Perpendicular means, you got to remember this, perpendicular slopes are opposite. In other words, if one's positive, the other's negative, and reciprocals. Pretend that spells reciprocal. So it's got to be opposite, so it's got to be a positive, and it's got to be reciprocal of 2, which is a half. And there it is. You got to remember that. You got to know in your brain, you can't forget that perpendicular lines, opposites, and reciprocals. So there are 2 or 3 things there you just have to have filed away in your memory banks in order to solve a problem like that one. I think we wound up stopping right there. So I'll stop right there again. Try those. If you have questions about any of it, feel free to bring it up in class. I'll be glad to work with you. Have a blessed day.